Okay, so this is like a very cut and dry way of looking at things. So I don't know if it's the right way, but I've split it up into 3 different categories. One is, the first one is figuring out kind of what the information is that's transmitted across the AI bus and how that's, what is that information? The second one is each module has to operate on that information. There's various things that have to happen. So these are sort of questions along those lines.
No, wouldn't that be like some of the modules could do different things, right? It's not like, or are you thinking like, how do they all interface to the bus?
Yeah, they're strongly related, but things, I'll walk through the details of it, but.
Because my mind is like different modules can do different things.
Right, but the AI bus operations would be common.
Yeah, so it says operations modules perform on the, I see.
Yeah.
Yeah. Well, again, you can look at 2 ways, like how do they work with that information, but also they could do different things with it. Some they,
Yeah, and then here I'm trying to get at the generic stuff. But vision module might do something very different.
Well, I was thinking also like the sort of the episodic memory type of module is different than the standard.
Yes, I don't even have that here. Yeah. And then the third category was stuff inside the modules that we've talked about that's common and unclear whether the episodic memory would do this stuff or not, but things on the graph and updating based on motion and stuff like that. So I can go through each of these in more detail, but this is how I kind of split it up. And I'm not saying this is the right way to do it, but the first question is stuff that we talked about last time when Marcus presented. So how are object ID, location in the external, relative to the body, and orientation, how are they represented? So in the last week, there's tons of options that have been mentioned, like SDRs, lists, vectors, particle filters. This thing, DDC, is I think it's like distributed coding or something like that. It's a lot like SDRs, but with probabilities. It's kind of an interesting thing I just threw up there.
Is that a known thing?
There's a small community of people working on it. They can talk about stuff that's similar to SDRs. But they don't really talk about it in the context of high dimensionality and sparsity, but there's relationships there. So I think there's actually a nice match between SDRs and DBC, combining those two. Anyway, then there's a question of how much of the representation is learned. And Marcus presented kind of extreme view last week where the entire thing is learned and by backpropagation. Then there's the issue we discussed last time is how much information is represented jointly. Are these 3 completely separated, or is it on the other extremes, everything completely joined into one representation? So those are the questions to go through. A separate thing is, how is uncertainty represented? I think we've talked about a couple of different ways of doing that. It's clearly tied into this representation question.
Although the ID, there might be different answers to these for location and orientation than for object ID.
Yeah, that's why I've separated them out.
Oh, I see. I see.
But if we do them all joint, then they would be the same thing. But yeah. I also think they might be slightly different. But how are location or orientation uncertainty represented? And then how does the voting happen? How is uncertainty resolved and ambiguity resolved? This is one where you could imagine that it might actually belong in number 2, but perhaps there's something just in the AI bus that does this.
Well, the representation scheme would might dictate how that
goes. It is this. Yeah, these are all really tightly related. Is object similarity represented? So this is a new one I put in after the discussion last week. Or are all objects distinct? I think we all really like the idea of having similarity represented in the representation. This question came up last Tuesday. How do we need to represent and communicate the current common location? For example, if it's represented in relation to my body, what happens when the body moves? What happens if it's related to something else? Do we need to communicate that common point?
This is one where you could really deviate from biology. A lot of people wanted to. I think the only important point at this point is that at any point in time, every participant on the bus knows how to generate their object to body information, and therefore everyone needs to know where they are relative to that common point. But that's something that could change. Like in human, like we think about your body, our body moves steadily through the world, right? But in the system like this, you could abruptly change everything. So the question is.
But then would you need to communicate it?
Well, yeah, you have to, right? The question is, you have to, because everybody needs to know their new. If I was a sensor, I have to know the sensor, my relationship to the common point.
Yeah.
And I'm just saying, in a physical body like a human, it just you could even imagine. I'm just saying, I'm imagining scenarios where this is abruptly done, and yes, you'd have to communicate it. And I guess the question is, do you communicate? Everyone has to know where they are relative to this common point. So I'm just thinking out loud here.
We don't all have to consider this, but I'm keeping myself open to the possibility that the common point changes with every attention shift. And
that goes back to
that's a very valid
thing. Yeah.
I'm trying to at least hold that possibility in mind, because that might be interesting.
It doesn't seem that way introspectively, right? If I'm sitting here and attending to things in the world, and I say, well, where things are, they all feel like I'm still perceiving them relative to my body. When I turn over here, I don't feel like, oh, the cup has moved relative to my body. My sense of where's the cup, if you ask me where the cup is, I would say, I feel like it's in some position relative to my body. The ask for Subutai is, I feel like some position relative to my body. It doesn't feel that that's changing every time. Well, you could, I guess, as long as everybody knows, it has to be communicated somehow. I was even thinking of something like, right now our sensors they all in a body, your sensors move sort of, they all have some movement and continuous flow. Even your eyes are cutting, it's like a continuous, like I know where I am on a path and break. But I can imagine a system where you have a bunch of sensors, and they imagine they learned how to model movements at a factory floor or something like that. And so they all have some common point. And then you want to put those sensors in a completely different arrangement, and maybe in another room, another point in the factory, right? And then there's 3 other cameras in the other point in the factory. And you want to switch to those 3 other cameras as if you hadn't switched, as if they moved there. Well, those 3 other cameras will be in different positions relative to each other. So you could instantly switch to these 3 other cameras that are in different positions relative to the first 3 cameras. The system would continue to work. It would just say, yep, okay, now my three eyeballs are in different positions over here in a different part of the room. And so it would be this very discontinuous flow. So somehow that has to be communicated to everybody. This could almost be like a preset thing where you set up a system. You can say, okay, here are the different positions. If the sensors actually weren't moving, if they were just in different positions. I'm just riffing on this question.
Yeah.
It's kind of a related thing there where for location of my sensor, say on my fingertips, I can only move so far from something that I'm calling the location of my body, but in a system with like robots just running around, there's no longer just an epsilon ball you can draw around the body and say I'm always here. So tracking.
Well, what if the robot moves?
Yeah.
Yeah. Well, your body can move too. So how's that different?
Because the distance of like a sensor of like my finger to my body, that's fixed. I can only go so far.
What if you're a robot? Isn't your finger fixed to your body or fixed to something?
I guess I'm thinking of a distributed robotics system where you have a bunch of different robots and the bus is more like online.
Okay, so like, is that sort of going to the camera situation I just said?
It's more like the camera situation, but now the cameras can all move.
Yeah, or like I guess the equivalent would be, imagine you had some robotic arm that was manipulating something and it's going down. I guess this, bear with me. It's going down the conveyor belt and it's working on something, and it doesn't finish, and it gets out of range. Well, the next arm down there could pick up exactly where this one left off, as if it was the same arm. It's like saying, "Oh, okay, I'll continue working down here," or something like that. Is that what you're thinking?
That's a cool idea. I guess I was more just bringing up a challenge to keep in mind. It would possibly be more powerful if we could have, many robots using the same bus to communicate, because you relax the constraints of having them all be in the same spatial location, but it introduces an extra challenge of mapping where they all are relative to a common point.
I think the thing is, one of the restrictions of this system is that it's really only useful if multiple sensors can be sensing the same thing at the same time. In some sense, like, because what you're communicating is observe things relative to some point, right? And if there were some sensors in room A and some sensors in room B, and you couldn't easily explain how the ones in A and B can't really observe the same thing at any point in time. So you could switch from A to B and B to A, but you couldn't be observing the same thing from A and B at the same time because you're in different rooms. So at that point, it gets a little harder to, they could know where they are relative to them, but they really can't. At any point in time, the sensors in A and sensors B can't really talk to one another in a useful way because they can't observe this.
But they can't agree on the object.
But they can't be observing the same object. So my point is, it's only useful that there are two sensors like my eyes and my ears and my fingers can at some point be observing the same thing or attending the same thing. And then they have a way of communicating with each other. But if they can't do that, there's other ways to communicate, not directly on the bus. You know what I'm saying? It's like language.
Yeah, that's what I was thinking. Somebody could just teleport this.
Yeah, but the major benefit, or one of the big benefits of this is that the reason these things can work together is because they're observing the same thing, different positions, different orientations, but they're observing the same thing. So it's just part of the benefit of that.
So I have a question about this object similarity. Our object instinct. How's that work? Because I'm looking at the whiteboard here. There's different E's in this whiteboard that are all different. And there's about a E, LRE. That's an example.
I think there's a different issue. There's sort of like, how do you take E's of different shapes and classify it as an E? That's like endless.
Right.
But then this is an E and an F. They have similar representations.
Okay,
They're different objects, but they're
different objects,
similar.
not the same object.
Yeah, yeah,
Like different scales, doesn't matter scales in that case.
correct. Yeah.
But there's an issue we haven't really addressed at all, and I'm not sure how much we have to address it up front, which is the sort of the state of objects, right? And so we talked about the state of objects like laptops open and close, or what's going on in a smartphone, or stapler, and so on. And one could argue that like an E and an italicized E and a bold E are different states of that object. And I'm not saying that those differences all can be understood as states, but there are lots of objects in the world which don't have a very rigid morphology, and yet we see them as the same. Yet we know they're different.
Right.
So I'm throwing into that same bucket this issue of state, which might be the same solution as the issue of like, I don't know.
But that's not similarity. That's state.
Well, there is similarity. I mean, a stapler is a stapler. I can say it's similar. I know those two things are this similar in some sense. They're different instantiations of the same thing. Just like the italicized letter is, or my handwriting might be different than your handwriting. You might be able to look at my handwriting and say this, Jeff, so I can look at yours and say this, Lucy. I'm just saying there's the spectrum of different things that are different in the world is something we haven't addressed at all, and it might include state.
So I put that in here as G.
I think we can do some very, very useful things without solving that problem initially, but we do have to solve it eventually.
Yeah, maybe like both of these, it may be something we can figure out later.
Yeah, there's a lot of advantages to this architecture that come from just having the plug and play architecture of the bus, and you would limit the number of applications you can do, but they're still pretty quite good.
So I think the point of this is, this could help structure our meetings. We could focus on these things. In terms of what operations modules perform. So one is the thing that Api asked, how do we do associative learning of object ID, location, and orientation? So how do the different modules learn to do this thing? Very related, maybe the same question is, how do we implement many-to-many mappings between modules? So it includes sort of one-to-many and many-to-one. So one, and if you have an audio module, it has a certain sound, but that could be associated with many different visually different objects. And so from the audio standpoint, it's just one thing, but you'd want to associate with many different physical objects. This one is sort of, you just mentioned this idea of sort of sticking in a module and having it work. And what does that mean when a module inserts itself into the bus? Again, maybe this is something we can punt on for a while, but what happens when?
I can see how that could work in a system that uses sort of the sparse representations with associative memory. I could explain that. How you could design this. I mean, I think in a real brain, for example, if I could add some new columns to a cortex, they would have to learn how to talk on the bus. They would have to learn all this.
Yeah, and then there'd be new wires and new axons at that point.
Yeah, or they would
hear what
yeah,
actually
I
happens.
think, but I think if in an engineered solution, there are ways you could make it so that you could instantly plug in another camera and it would be useful. So I'm happy to go through that. I can understand that from the sort of the model we did in the Collins paper. So I could explain that, but
Okay,
I don't know how to do it in other systems. I think it'd be a really nice attribute to have. I don't think brains do this, but
Right,
I think this would be great.
Yeah, and then this is a big question, obviously, but how do we transfer knowledge from one module to the other? How does that happen?
I had some additional thoughts on that. I can share.
So I think each of these could be like a topic that we dive into.
They are.
They are. And then within a module, this is sort of what a module needs to be able to do in order to participate in the AI bus. How are internal locations relative to the sensor and orientation, how is that represented? Maybe we don't need to specify that generically. How is the pose calculated, the thing that you're going to actually transmit on the bus? How is the graph represented and constructed? How do you query the graph? How do you, when you move, how do you update this external sense of the pose? And then how are internal reference frames represented and updated? Again, these are all sort of very overlapping questions. They may basically be the same thing, but I split them out here just for purpose of discussion. So that's pretty much.
Would one of these? So I think one of the core areas that's going to need research is unsupervised learning of a bunch of reusable parts. Would you say that falls under any of these A, B, C, D, E, F? Or like, how do you learn a good set of parts, a good set of objects that you can now construct other objects from?
I did not include that in here, so that would be a separate question. I think, unless you.
Yeah, one of the nice things about attacking this from a bus structure is that if you think about one of the modules that's on the bus, like a column, you have a lot of flexibility how you implement that, as long as it works to the protocol, right? And in some sense, it's like, that's why, I've said, hey, I don't care how you do it initially, because as long as it works the protocols, as long as then the internals don't matter. And that way we wouldn't get stuck up on saying, oh, well, we don't quite know how the neurons do this, or how we do that, or something like that. You could do, you could come up with partial, engineered solutions that maybe don't learn as well as you want, or don't have all the kind of representations you want internal to these modules, but they, at least whatever they do, they communicate properly and they adhere to the protocol. So then they're still useful. It'd be like, think about it from a biological point of view, there's all kinds of eyes, right? And there's some that are very primitive, some that have colors, some that don't have colors, some that just don't focus, some that are multi lens eyes, all different types. Some are better than others, but they're all useful. And so you could think of it that way too. You could say, okay, there might be the ideal way of doing some modeling with a particular sensor, but we could get started with one that's less than ideal. And just sort of put that in its own little box. You can imagine teams working on that on their own independently, upgrading inside of that box, inside of the module.
I guess one question is, in terms of what's transmitted on the bus, is there a difference between object IDs and how objects are transmitted and object parts are transmitted? Or is it basically just different objects as far as the bus is?
Well, it's just, this is the operations within modules is.
But it's trying to get at the generic operations within the modules that every module would have to do.
Well, I don't know, you know, again, I think,
And so if it impacts the bus or things that it would be in here otherwise.
I can easily imagine there's a module that has no learning whatsoever, but it works on the bus just fine.
You could have, they could have different kinds of graphs. Some of them might represent their graphs in different ways.
Yeah.
Yeah, so maybe these are not generic then, like we don't really.
Well,
They might be important, but they're not.
We're
kind of
gonna
generic.
have to build some of these,
Well,
so we'll have to decide how we want to build some of them, so that from that point of view, they're generic, but not like no one has to think about them. So we're gonna have to do
But
something.
the representation could be completely different.
It could
from one
be,
module.
yeah.
per module,
Inside the module, that's why I said I don't mind if people want to use standard, you know, CNNs or ANs inside the module, because that may not be the way the brain does it, but it doesn't really matter at the moment. We want to build something that works, and therefore, as long as the module performs the right functions.
Yeah. but how do you communicate from module to module?
Yes,
You don't know
the
how to
same
compare
could
it.
be sent.
No, if you adhere to the bus protocol,
When you want to query something in the graph from module A to module B,
so it has to be able to do that.
so it has to know about the graph in module B, by the way, it has to know something.
It doesn't, it just needs to know that it can ask what is at this location or what is at this orientation at this location. If I can, the query is in the form of,
So the query has to be global.
the queries have to move over the bus but they're all location-based queries, right? Which is,
Or object-based query.
or object-based queries. But not all modules would be able to answer the object-based queries. If I asked, you know, which is, you know, point to the red cup, the semantic sensory system can't do that. Right? My hand could know there's two cups here, but it can't tell you which one is the red one. So not everybody can answer every question.
So maybe all of these could be different in modules. Any of these, as we don't really care as long as it outputs the.
I think that's right. Yeah. Gotta be able to do some communication on the bus that's useful. Does that make sense?
Yeah.
You can imagine, you know, I imagine this as an established platform, and you have lots of different companies and people working on the platform. Different people will build different modules. They'll say, I'm an expert in infrared sensing, or I'm an expert in this type of sensor manipulator or something. And they can build that module any way they want, as long as it communicates properly.
Well, coming from the enterprise world,
Yeah.
that module sometimes has some kind of bridge or interface that translate a message from one to the other.
But
Just
no,
make a document, for example, an invoice from one
yeah, but
company to the other.
the message that's the figure, that's number one up there, right? But it's gonna be in this language.
But the module A wouldn't know about module B in that sense when they communicate module A to module B. They don't know how to translate from an object to module A to object to module B.
There's no internal knowledge.
That's the question.
You know, the module that's relating the sound of something to the visual aspect of the something, the auditory module does not know what the visual module knows. It doesn't know anything about it. They've learned to associate with one another. So the auditory module said, I'm sensing this at this location, and then the visual module says, oh, well, that corresponds to things I know. And I know it's at that location. Maybe it's the thing making that sound. But it doesn't have to know anything about the internal structure of what it knows about it.
We should know what can query.
It queries again are in this format of, I'm looking for this, something that's associated with this ID, but it doesn't even have to be the same ID. It just has to say my ID corresponds to some of your IDs. And it doesn't need to know anything about it. That's the beauty of this. One module really doesn't need to know what's even going on inside other modules. The language of the query is in the first set of objects we have to decide. Object ID, location, orientation. There might be other things that have to be transmitted. We talked about state as an issue, but at a minimum, this is the language. So all queries have to be in that language. We're trying to avoid the idea of any kind of internal. I know what's inside of your model.
Right, that's the part that becomes complementary.
Yeah, but it's right, that's the beauty of this is you don't need that. You just don't do that. But this is the language of the bus, and therefore everything has to fit into this language, or some superset of this language, right? Some other thing. But you're trying to purposely avoid any knowledge about what the particular sensors know and how they work and their internal machinations, you know.
Ask a question, what binds the associations together? What learning process binds the associations together?
Well, we haven't decided that.
And
That was
that's
the
related
question.
to obvious question that we're gonna get to, is the bullet point on the upper right.
Yeah, I mean, I can say how it works in a neural system, I think, you know.
I mean, we have a particular way that we did in the Collins paper.
Yeah, that works. So we can, that's one method.
It's a starting point.
Just
I
an
don't know if you wanna do
association
that.
of sparse representations. Your set of sparse representations. So that yours involves mine and mine involves. Pretty simple from that point. That's a pretty, I mean, Marcus proposed something different last week. But we should all at least understand what we did in the Collins paper. That's a very simple version of it. It works.
We walked through that in the voting.
We did.
presentation,
Went through
yeah,
that multiple times.
detail.
Doesn't mean everyone internalize.
So in that case, there's no common language for you to say.
Right.
Yeah, there's no common.
There's no common language.
The common language is orientation. It's not even a language. It's not even a common representation. There's no like format which is passed over the bus.
Right.
It's everybody has their format, and then you socially link them.
And then in the Collins paper.
Which is, I know it's different than most things in computers, well, I find like that, but that seems the way the brain does it, so. And there's a lot of power to that, whether you're doing it the way Marcus presented it or the way that we did it. Do you want to dive into one of these now?
I don't know. You had something you wanted.
But I thought, well, I do, but I think we have to start tackling these things.
But to me, this is still the first place to start. This whole thing.
Yeah. Well, let's start with this question. We have these three variables there. At the moment, I think they're sufficient to get started. I don't think they're sufficient ultimately, but do we want to debate that, talk about it? Does anyone see an obvious hole? I mean, things it doesn't represent state. It doesn't represent any way of, commonality between objects. I'm not sure that's going to happen. It doesn't represent any kind of actions. I'm not sure you need that. You just, actions could be defined by a series of these over time. But it doesn't represent actions. It doesn't have any of that there. I don't know if there's anything like that. But this would let you do inference of static things.
So we're looking at sequences being a problem that comes later.
No, well, sequences can be handled two ways. They certainly have to be handled within each module, right? Each module can run sequences. Each module can predict what's going to happen in its little world over time. The question is that knowledge shared in any way over the bus, or is the bus really just a representation of its current state? Like, imagine I model how the staple event works. So I'm a module, I do that. I could just put out a series of objects and orientations over time. And that could be it. I could just put out a series of those, a constantly changing representation. And therefore I'm not actually representing any, there's no actual representing of the sequence, it's just encoded patterns over time. Or there could be a separate sort of representational concept of oh, like state, like, oh, this is the open stapler, and this is the stapler is closing, or something like that. In which case you would pass something information like that over time. Here's the way I was thinking about this. Imagine doing a language module. And the language module is looking at the bus and wants to describe what's on the bus in language. Well, you could easily say, oh, well, there's this thing over here with this orientation to me, there's a cup over here, and it's facing this way, and there's this thing over there, you could do all that. But language also includes actions like, oh, the water is flowing, or the car is going down the street. So how is it getting that from the visual system? Is the visual system just reporting a series of, like car here, car here, car here, car here? Or is the visual system saying, no, this is a car moving in this is an object moving in this direction relative to the body? It has a trajectory relative. We could pass that information as a trajectory as opposed to just a location.
So both being able to recognize external sequences, but also be able to generate internal ones.
Well, it's going to definitely generate internal ones. The modules have to do that. The question is what goes over the bus, right? Does the language area say, oh, I'm seeing a sequence of car, if we're going from this point to this, I will describe the cars moving, or is it the actual something else transmitted on the bus where you associate that thing with the verb, driving and moving? I don't know the answer to the question. I'm willing to go forward just with these three things, but real limit what the system can do. I think over time, as we build these things out, we'll learn so much more and we'll figure out these things as we go.
One thing I see is missing is a coordination mechanism, and abstract that away and say, yeah, things arrive when they need to, deliver what they need to.
You're talking about in time?
I'm talking, yeah, in time. But also just being able to.
A bus synchronization thing?
Yeah.
Ah, that's interesting. Well, that's interesting. So that's more like a substrate question.
It is. It's a question of whether it can be abstracted away or whether there's some fundamental properties of it that can be leveraged.
Maybe, but let's just talk about a substrate question.
Mm-hmm.
Like one substrate, you have neurons, and the neurons are sort of active all the time, and they go through, maybe they're cyclical, at some frequency. But they're active all the time, and there's really, so maybe they're all cycling at the same time because we're attending the same thing. You can imagine these, the transmission times have to be short enough so that they kind of arrive at the same time frames if needed. But now if you're going to build this in software, for example, how are you going to do that? And what would be the substrate for building this stuff, actually?
Yeah, it's, the two ways you normally think of it when you break it apart is either you are event-based or you're time-based.
Yeah.
But in this particular case, it's interesting because we know that waves propagate across. And so there's not only just the point-to-point communications delay, but then there's a purposeful rolling wave of synchronization that goes across the brain. And again, that could be abstracted away.
Yeah, I think that I would see my first guess you would abstract that away, right?
Mm-hmm.
I mean, we don't want to model all these biophysical properties in neurons.
Right.
So the question is, how would you could do like a clock-based system. You say there's the system's running on some sort of clock.
Right.
Everybody posted, these
Or
times.
is it self-timed and it just emerges that you have a wave coming through?
Well, what if we took the simplest approach possible, which to me the simplest approach possible is you assume a sort of clock and everybody's working on the same clock. Not a biological solution, perhaps, but it could work just fine.
Mm-hmm.
That's just pretty much what PyTorch does when it distributes. It's just a discrete.
Right.
Is there any harm? Is there any downside to that? I don't know enough about these. I don't know.
And a lot of advantages.
Yeah.
It's more
So
simple.
what are the
Yeah.
downsides to it?
The downside, well, not the downside, but if the brain has adapted to a finite propagation delay, it might treat long connections phenomenologically different than local connections that could, get within a certain.
But let's
phase.
again, I could argue that could be abstracted away in the individual module. So let's say I have an auditory module that's doing speech recognition.
Right.
One could then say, oh, well, I'm going to be, I'm gonna be posting certain recognized spoken sounds. And I'm gonna put them on the bus and at any moment in time, I'll have to say what my current one is. Although the actual temple structure, very fine temple structure might only exist in that module.
Right. I guess the distinction I have is whether you see the coordination as a defect to be overcome or whether there are properties emerging from it. For instance, if you have an exponential decay of a signal, you naturally have locality and things are based around that. Now, whether
How's that locality?
If
I mean, how far away I am or something?
yeah, you get a stimulus here, and let's say the myelin only is
So I would think myelin, the moment, I don't know, I'll take a position and see if someone wants to go opposite. I would take a position, this is the problem with the brain, has to get around, and it does all kinds of tricks to get around it. But for the purpose of the neocortex communications layer, not within a common communications layer, that it's not useful and it's more of a problem. So that would be my first take on that. But that's just, I'll take a stance. I'm going to be always shooting for the simplest possible thing to do right now.
okay.
And we'll see if, and then you have to see if that's too simple.
Okay.
I mean, in terms of distance and things like that, those would, each module kind of has to figure that out on its own and transmit it. So
I mean, I don't think it's an advantage to the brain that the area representing my left hand is pretty far from the area representing my right. That's. I still think that's an advantage. I don't think it takes advantage of that. If it could be everything could be tight together, probably would do it. So anyway, that would be my first stance. If I say, okay, you're gonna have a bus structure here that we would like to act as if there's no delays on the bus. That would be my first guess.
Yeah, I think for the goals you put down here, that's a good assumption. In the back of my head is, how the brain kind of constructs itself, during growth and stuff like that. It was featuring back to why the brain does the way it does, but that's not true to what you're trying to solve right here.
Now we're trying to capture the essence of what the information
What
processing
the
is
actual brain
happening.
does.
Yeah, and we're not trying to recreate a brain. We're trying to recreate what the brain does. And there's always this, questions that we're going to be all asking over and over again is what can we abstract away?
Yeah.
So I would abstract away the timing issues there.
Okay.
So I don't know enough about PyTorch or any other, whether that's important to know about this. I mean, this is like a very basic software.
Yeah, I mean, what I'm-
synchronized,
yeah, my point is all the basic substrate stuff of communicating and all that, that's just easy to use.
Yeah, okay.
You don't need to worry about.
Well, I think
These kind of questions are much
which brings up
more
the question, that's why it's easy unless you want to do the kind of stuff that Kevin's talking about. So I'm trying to keep it easy. So, I mean.
It's only important if it actually fundamentally impacts any algorithms or.
Yeah. So I think the purpose of this meeting is to just discuss these things. We're going to take a whole bunch of assumptions and we're going to find which ones are correct and which ones are wrong.
Yeah.
So I think we can pick that one. So the underlying communications protocol should be pretty simple then. Right?
So, because I missed the first meetings, I just want to understand something very fundamental. When you, where are we trying to, with this AI bus idea, where are we trying to strike an aesthetic boundary between neuromorphic, driven by neuromorphic, and machine language architecture? We're trying to pick something in between.
No, I'm going to try to write anything no more. Anything.
Okay.
Well, that would be, I want something we can build today, right? And so
Okay.
neuromorphic hardware is like not really today.
Okay. So the AI bus is really that notion. It's
It is.
artificial.
It's yeah, it's capturing the essence.
No, I understand.
Yeah, no, yeah. I mean, the I see as a goal here, this is something we can build today.
Right.
It's going to be useful today.
Right.
Today being a year or 2 years.
Okay, so it's useful as opposed to saying, yeah, we're trying to explain the brain.
No, this is just be really clear. This is moving down the path of creating an architecture for AI that
Okay,
is valuable today.
Like I said, I missed the
Yeah.
first couple of meetings,
Yeah.
so I didn't necessarily hear where that was
Yeah.
laid out, so
No,
I'm gonna ask that.
I'm
Okay,
viewing this as a technological platform that people can use.
thank you.
It fits with our second goal of the company, so that's just, I want to say that over and over again, it's not a change. The second goal.
Logistic question, people online, when two people in the back corners of the rooms are talking at that volume, can you hear them very well? Someone?
Yep.
Yep.
Okay, cool.
What I found when I'm online is that people in the corners you can't hear very well. So Ben and Abdi would be more difficult. It's surprising. That's what I've noticed.
Ben's pretty close.
So we can put that aside. We have these three IDs, these three variables. I think I'm nervous that we might be missing something really big. We'll have to do right away, but we don't have to. We can start with just those three.
Like in the solution, like Marcus presented, there was an other states that was passed to the bus,
Well,
not just IDs.
That was, what was that, Mark? I thought that was as a placeholder for.
I was letting everything just fall into one thing. It could be object, state, ID, location, orientation. Let it choose how to represent it all.
Yeah, but we don't know how to do object state at all right now. So we have no theories about that. I don't have a theory about it. I don't think we've discussed one here, so that's like, boy. So let's not deal with that right now. I think, Marcus, I think, is proposing, well, you can just add things willy-nilly and they'll figure it out, right? Or something like that.
Yeah.
And I think that might be true no matter how you represent these things. So that's a possibility as well.
In the framework, we try to represent the stapler open versus closed and grid cells, right?
We were
Displacement
representing,
cells,
we were
yes.
representing how a module, one of these modules could learn what a stapler does. How could it learn the staples opening close like this and do a series of displacements? It could do that, a sequence of displacement. These modules here can still do that. The question that the problem is that we're dealing with what is on the bus. Remember, everything goes back to, we're going to define this bus, and the bus is going to be the chain here. And so internally, a system can, oh, the stapler open and closes, and the stapler closes out. Does that magically, knows how to do that, maybe using displacement.
So you can use the displacement cells for your state, right? It's just a question of how does that get, well, that was what you said, Marcus, right? We don't know how to represent state right now.
Oh, state. So,
Yeah, sure. We don't. Jeff just said that just 2 minutes ago. Also,
So then, I guess within the module, the displacement cells can be used to represent state, but it's just a question of how do you convey that information on the bus?
I don't, take away, we had one idea of how displacement cells work in the columns paper. Marcus proposed that actually displacement should be viewed in terms of vector cells as opposed to grid cells. So it's the same idea, but in a different representational space. And I think that was really clever. I don't think that kind of displacement, I have to think about this. I'm not sure. Can that be something that could be shared on the bus in a meaningful way? Like, it has to be something that can be shared that other people don't know what it means, and they have to learn how to associate with that. I don't know yet. We have to start thinking a lot along these lines, like what could be shared on the bus that's useful. For example, the displacement, if it's all in the language of local knowledge that really doesn't translate to other people, then maybe it could be on the bus. I don't know. But it's good. The system's going to have to deal with this one way or the other. Either that kind of state information is transferred on the bus, which it probably has to be some way, or in the movement information is transferred on the bus, or it has to be recreated on the other end through a sequence of static, a temporal sequence of static things.
Like you said earlier, you have these different sparse representations, and you learn to associate them together. So
Yeah.
with state, it could be that you're using displacement cells. If you can get a sparse representation that way, then whether you're seeing the stapler open and moving your finger along it, you get associations between different sparse representations.
Yeah. Imagine you have something like this. You have a series of sort of a static impressions, like you're seeing something and something's moving, like the stapler is moving, but I don't think it's static. Its point is there's just something's changing, But any moment in time, you just have some representation of its current position.
This is a sequence of states.
Yeah, and then you have like a temporal memory that learns this sequence, right? So now you can play it back. You can say, well, given if I'm in one of these sequences like a melody, I can predict the next state, and then I can predict the next state, and so that's the way we thought about this working. And so this could go back and forth. The sequence learned here, and this sequence can predict what's going to happen next. Now the question is, what do you put on the bus up here, right? Well, option A is you put these things on the bus, and the bus, there's no information about this here. And then anybody else who's extracting information off the bus would have to recreate this and have to learn the sequence. That's one option. I'm not advocating for that. So this would go into another module over here, and it's feeding a series of states. And then this guy over here says, oh, I can learn that sequence too. The other option would be to say, no, we want to send something about this up on the bus. And then that can come over here and inform that. I don't know how to do that, but maybe it's possible. So that's just the two options we're talking about there. The bus itself would know something about this information, or it wouldn't. It would just know this.
So, I was thinking about like what queries I want to do in the bus. Sometimes I'm not clear about the state of course, like what's burning.
What's what?
What's burning? What's burning in the kitchen? That's a question.
Is that
A state, something's burning.
okay? That's less querying the model, I suppose, as to saying go look and see what.
Right, but like that's the queries. Would you query something like that in the bus? Like, what the state?
I think in some sense you could. You can imagine two modules on the bus, right? Let's go to sound and vision. Right. The burning is sort of an exception state. It's like you don't normally think burning in the kitchen.
Right, but like what's making the noise?
Okay, right. So
Something just happened.
Well, let's say I'm going to first address the question, not the unexpected noise we don't know. We'll come back to that right now. One, you can say, I hear, like we talked about the train before, right? I hear a sound over in that direction. It sounds like a train, but it just is a sound. The auditory column says, I hear the sound. I know what the sound is. I recognize it before. And it says, here's my ID. Here's where I think it is. And then somebody, the other column will say, well, I know that sound. I've associated that sound whenever I see the train. And you say it's over there, so I should expect to see the train over there, right? Or the auditory column, the visual column could be looking and seeing a train, and it would say, and then the auditory column would say, well, given trains, I often hear the I've associated your train with the sounds. I can maybe predict I'll hear the sound. So that's a kind of query. It's like saying, I don't know if it's a query, but it's an association. I could then, but I could ask a question like, I'm trying to think of a query that would be like, you want to say, well, what is at this location, or where would I find this?
But you limit questions to locations and objects, not to state at that point.
Well, that we don't have a state representation.
But that was the first question. Is there those three objects in there?
Well, I think it's enough for certain applications. And so this is why I wanted to get eventually to this thing, but we don't have to do that right yet. I think, let's say we go build this system, and let's say it takes a fair amount of time to build it. We're going to want to have a set of like capabilities we want to demonstrate at the time we're done.
So this is scope. So
it'll be like the first set of features that the system supports. And so we're going to want to at least have that as a minimum set in our mind, so we know what we're completing it and it's working. If we're achieving our goals, it won't be everything. It won't be saying I smell smoke or tell me what food is burning on the stove. I don't think we'll probably have that right away. So I have ideas for this, but that's why I think it's important. We can't build everything initially. You have to start with some usable subset. I think this is a usable subset, but we won't really know until we start laying out the capability we want. So maybe we could, I don't think anyone of us knows right now, I'm not hearing it, a proposed additional thing for this list of three we have. That someone can make an argument like this, I believe is really gonna have to happen. It should be. If someone does like that, please say so. Now, I think these other questions, I'm prepared to talk them from like a normal point of view, but I'm not sure, Marcus, you proposed that way of thinking about this, but I'm not sure these other questions are even important anymore. If somehow magically they also get resolved. I mean, I don't know, like how you represent uncertainty and how you represent location and orientation. I can come at it from a biological point of view. I don't know how we resolve that.
One thing I'll throw in, I don't want to dominate the conversation. I took up so much time last week. The terminology I wish I'd used, in addition to what I used, I used very deep learning terminology. I compared it to autoencoders a little bit. I should have also translated it into our language. In some ways, what I was proposing last week was like a spatial cooler, but for space, because like spatial cooler for describing what's out there. For like basically everything you're saying, the object relative to the body, but doing it in sort of a spatial cooler way, where the traditional spatial cooler takes the sensory array and describes that in a way that has like the overlap property.
The thing that would really confuse me was not the mixing of the orientation or location,
Yep.
but it was the mixing of the object idea. I thought that was where I was like, oh my God, that doesn't seem right. That seems like again, like this real difficult to the system, and I couldn't see the benefit. Because a lot of the queries will be one of those two categories. I'm looking for this, where is it? Or what's at this location?
Okay.
And so it's when you mix those up, then you have this very, very, of course, combinatorial problem of potential number of things you could have. And it just seems like why would I go there? You know, I can represent location pretty concisely, and we know how we can represent object ID pretty concisely, but it's a combination of the two, which seems to get combinatorial explosion. So that's what was tripping me up about. If we could separate out those two basic ideas, then I might be more, then I can understand it.
The combinatorial explosion part, I feel like I can solve, but you just brought up queries. I need to think about that one. Yeah, how you does that break the idea of queries? That's a good question.
Well, I was assuming somehow it was going to work, but maybe it won't.
No, my point is right now that's the question I need to consider.
Okay. Well, I think that's really, really important. It's really, really important to be able to, for the system to ask itself queries and for an external user of the system to ask queries as well. And even if you're like, you have this episodic memory and you want to query the episodic memory, you know, like what happened, where did you observe over time? Imagine it's observing robots running around a factory and said, well, I saw this one go over here and then it did this and it go over here, that kind of thing. You need, you know, a lot of the queries internally and externally would be like, you know, where was this or what was that? And you know, what is the sequence of events that led to this? And so the building up this episodic memory seems to be an important part of this the capability of the system, and you have to be able to query that on those different capabilities, or just play it back. You know, just play back like here's the sequence of things that happen in a way that could be understood. So maybe you have to think about that. It does bring up, if you don't mind, I'll throw in an idea I had that it's sort of, sorry, but it's a little bit tangential to this, but maybe related to the various things.
I think we can be done with this. I don't think.
Oh, I don't know.
I can leave it up, but that's.
Yeah, leave it up. One of the things we talked about last time, not the Marcus conversation, but the time before, we talked about in one of these modules, there's a graph, and then there's, you know, it's inputs from sensor and motor, and it attends to some component, and that component is added to the graph, and then the more later, you know, that kind of thing. And we talked about how is it that that when you learn new graphs, they become these components. I'm sure Marcus, it's like they become a base unit. And then I recall in the brain, the classic story isn't like that. The classic story is fast learning only occurs in the hippocampus. This is, and the famous case of HM, they removed the hippocampus, didn't learn anything new. And that it's very well documented that model building in the cortex is much slower. It takes time, it takes months, actually. We talk about it often as it's very rapid. It could be theoretically rapid, but actually in the physical brain, it's not as rapid as we like it to be. And certainly without the hippocampus, it seems to be extremely impaired. I never could understand how the hippocampus could transfer memory, what it knows, to the cortex. And I've always kind of dismissed that idea. I thought, how neurons can't really know how to talk to each other like that. But now with the bus idea, I see it actually is possible. So let me just explain what I mean by that. Imagine you have the bus and you have a set of modules on it, different sensors and different actuators, but they're all modeling something, right? They're all sort of simple. These are cortical column equivalents. And then over here, you have your episodic memory, which is in the brain, that would be the hippocampal complex. And this we know is the fast, very fast, episodic, meaning it's a sequence of things happening in time, and it knows what happens in time, and it remembers exactly what occurred. And it is, as I pointed out, it is this sort of first-person memory. It is the memory where you were relative to things. It's, in some sense, isn't body-centric coordinates. And so when we go about our day, almost all the memory that we're storing for today is in this thing. What you did so far, this meeting you did earlier today, it's all over here in the hippocampus. Now, clearly, these things learn too. I'm not saying they don't learn. We have to train this, but this is much slower. In the brain, these are slower. And I've always felt like, well, we don't need to be slow because the brain is limited by synapses and various other things. So, but if I adopted this architecture, just accept it for what it is right now, it means that I can have a system where these are relatively static. They're not learning. I have to train them sometime. Yeah, they have to be trained. So, but once I get the system in a working state, then it'd be like me going about my day. As I go about today and I solve problems, almost all the memory acquisition is happening up here, and almost none of it's happening.
But aren't those also learning during the day slowly?
Well, we don't know, actually. There's the example of HM said that absolutely almost nothing is learned over time without the hippocampus. Now, that doesn't mean that we don't know. And then, of course, it's very much associated. There's a lot of theories that say only these get updated during sleep because, a lot of these memories seem to be formed during sleep. And so there's a lot of research about how the hippocampus interact with the cortex and sleep. I've always kind of like wanted to not focus on that stuff. And I used to say, like, look, I can understand how one of these things learns on its own. I don't need the hippocampus to do this because it has to learn on its own. So let's not worry about that. But all my pointing out is a practical system. If I wanted to deploy a system that does something useful, I'm building a factory robot and it's sitting there, soldering widgets all day long. I believe it has to have this component, but it's not clear to me that these have to learn all. That it'd be like saying, yeah, I'm going to go about my day, do what I'm going to do, but tomorrow is going to be a Groundhog Day, and I'm going to start all over again. And I'm not going to remember what I did yesterday, or I'll remember what I did for a month. Our memories here are sort of about a month long, that's the maximum, I think. You forget things here all the time. You forget things you already did this morning. But things can last for up, maybe a month here. But then somehow it gets transferred into this. So the point I'm trying to make here is that we have this issue that these internal modules have to learn and they have to build their graphs. We have this question about how it is that the graph that's learned becomes the basic thing, and I'm working on that. There's some issues about attention and all this stuff. But I'm saying from a practical point of view, you don't have to solve that problem right away. we could pretend it's like a brain that is, it's just going about its day, and it's all the model building is in one location. So this is where the graph would be constantly being updated. And yet, and these would have to be pre-trained, but once they're pre-trained, a useful system doesn't have to continue training them. If I want to create, you know, an AI Einstein, well, certainly these things are going to have to be updated all the time. But if I wanted to build a practical system that does certain things and instills aware of what's going on, and you can see things, can tell you what happened, you wouldn't have to have these to be static.
But the graph now is global.
Well, it's not global in the sense.
There's one graph.
No. Well, it's not. These all have a graph too, perhaps, but it's not being updated, right? So imagine these were just like I said before. They're just. I'm just saying we could fix these modules. They're not learning in a particular application, they're going to have some sort of structured graph as well. But my point is that the one that's updating rapidly, the one that's going around and saying, oh, no, this is where the food is on the table. This one's over here, this the chair here, and now I'm going to turn around and remember there's a chair behind me, so don't walk into it. That kind of stuff. That's all happening over here. It doesn't have to happen down here. So all I'm pointing out is that this learning problem that I've referred to, of like when does the graph become an element of the graph, or node of the graph, like the compositional structure, we don't have to address that. We can have a system that works and fix it, and then the graph building becomes here. This graph doesn't actually ever get transmitted. We don't have to have it transmitted to other people. But again, this thing could say, well, where was this node? And it's, oh, and then someone else could tell you where that was. And it says, well, where was this node? And someone could tell you where that was. So again, you pass around the node information, not the graph itself. So this was a simplification that would allow the system to be much just simpler and avoid some of the learning problems that you ultimately have to deal with. But it would actually still be quite useful. And this gets us back to the sort of more of the plug and play architecture that you really could imagine a set of pre-trained modules. And again, they might have to be trained for a particular application, maybe not, I don't know. But you can imagine it like, you know, imagine these were just built on some sort of CNN with some blue logic around them. And they can output the component of what they're seeing. Again, I'm seeing this here, I'm seeing this here, I'm seeing this here, I'm seeing this here. However they do that, then you could just plug these guys in, they'd all be the same. They could be different modalities, right? It doesn't have to have vision, different things. And then all the learning would occur here during the operation of the system. So it makes things a lot easier. Simplifies a lot of the development effort.
In this model, would theoretically, something happens and another mod, some consolidation of whatever that is appears as a new static module, and that's how you learn additional tasks.
I didn't follow that.
You're saying operationally, we don't need these guys if it's not relevant to,
We don't need which guy.
The static guys.
No, we need those guys. I'm just saying they don't have to be.
Whatever's represented in here.
I said these guys. All I'm
here.
saying is that these guys don't have to be continually learning. That's my point.
No, I understand that.
But we still need them.
What I meant was, we can operate off of this until one of these guys appears, right? If there's a particular behavior learned, whatever.
No, this guy doesn't do anything on its own. See, all behaviors are going to come out by it putting things on the bus, saying, like, I saw. Imagine you're looking at a bunch of things on a table and it's building a graph of them, and now its goal is to pick up object A. Well, where is object A? Right? It will know where object A is, but it has to tell someone to go pick it up. This episodic memory doesn't do that. It doesn't have its own actuator. It could tell, push the button, you push the button, or you push the button. But this is just I guess the way I view this can't do anything on its own, right? This is the ears, arms, legs, and so on of the system, And this is the thing that's sort of building up its working model of what's going on right at the moment. And so when it wants to do something, you say, well, go find the coffee cup, and say, well, I think I know where the coffee cup is in space, but it doesn't have an eye, or it doesn't have, it says, you know, in this location, you should see a coffee cup. And then it puts that information on the bus, and the eyes will turn and go, oh yeah, there it is, or not, or something like that.
So I guess I'm not understanding what this subsumes. You're just saying it knows what the configuration of things are around it.
No, I'm saying
fast?
this is an episodic memory. So it basically, it recalls the activity it stores the activity on the bus, for whatever reason. It just stores the activity on the bus. Like, this is what actually happened. That's what episodic memory would be. It's saying this was here, and then this was here, and then we moved over here, and so on.
There's a time.
Yeah, well, that's how this is all well-researched stuff in the hippocampal episodic memory literature. There is a time sequence to it. It's literally why it's called episodic memory. You can remember these episodes in time, and what happened at those episodes in time. So when you recall what you did, and you say, well, I did this before that, and then I did this, and then I did that, that's all in your hippocampus. That's where it's happening.
Okay, so you're describing a recording mechanism.
Yes.
What triggers it to actually output something on the bus?
Well, that's a good question. I don't know the answer to that question.
I'm just assuming every iteration. Just
Well, no, like I think maybe Kevin's asking what's the system going to do, right? In some sense, you're asking, well, how does the system do something? How do I get it to make something happen? Something like that.
Right. Well, I mean, if this is a, I'm not saying you said this, but I'm trying to take it to the extreme. This is a pure recording mechanism, and this is a pure action mechanism.
No, it goes both ways. Maybe I was right there, but it goes both ways, right? This is a recording mechanism, but also it can put information on the bus as well.
Right. But what's going to trigger it to put out?
All right, that's a good question. So this is in some sense a modeling system with sensors and actuators, if you will. And now what's it going to do? What's the purpose of it? Like, what's its goal?
Right.
Yeah, that's not shown in this picture. That's a good question. One could imagine, you could imagine now that this is the temporary modeling built of the world as it is now. Right? So, you know, as you can think about is everything you know about today so far, where you are, what's happened so far, all here. We could then query the system and say, well, you know, where is something you saw today? And it should be able to say, well, I last saw the mashed potatoes at this corner of the table. We could sometimes, you know, voice of God comes in here and says, you know, where is X, you know? That would be on a language model, if you will, something like that. Or, you know, what is at this location? Or when did this happen? Then you'd be querying this thing. But if you tell this thing, like, for example, if you could say, you know, pick up the coffee cup, if the coffee cup was just temporarily placed someplace, that would only be in this model. It wouldn't be down here. Where the coffee cup is in your world right now is not down here. This knows what coffee cups are, but it doesn't know where it is. So this guy could then output where the coffee cup is. And if he said pick up the coffee cup, it basically would tell information about where the coffee cup is relative to the body. Right. And then we'd have to figure out who is going to actually go pick up the coffee cup. But the information, it would say, yeah, I know where it is because I just saw you, I just recalled we put it over here. Therefore, that's where it is, and anybody can go get it because now you all can translate where it is relative to the body. You can know where it is relative to your individual hands or whatever.
So just for argument's sake, this thing coming in, you know, from the external, that could be a separate communication mechanism, or it could somehow flow over the same bus.
Yeah, it could flow over the same bus. Well, it would in the brain, so we could talk about that. That'd be like language over the bus. I suppose we could try to give it, you know, I guess really, you know, this really gets down to the issue of what capabilities we want to demonstrate. What I can see here is a system that can do inference and prediction using prior sort of static knowledge of the world and dynamic knowledge of the world, as if the static knowledge of the world is like here, and the dynamic knowledge of the world is up there. And it can do inference and prediction from different positions. It can keep track of things. It will know things where things are, even if it can't sense them anymore. It would have a sort of situational awareness of its world. But what do you do with that?
But we also have a sense of time, but that's when did something.
Well, you would have that in that up there. You'd have that information. So yes. So
When, that's a question.
the question is, but what do we do with this system? It's okay. We got this system. What's its value?
At some point, I mean, the abstract thing is, where's volition? What initiates this thing so
Yeah, well,
the system does all this?
How do you apply it to something?
Right.
So I'm just saying, what is the system capable of doing? Before we ask the volition question, and I don't think that's the word we want to use. It's more like what we want the system to do.
Okay.
There has to be some goals for the system. What is it trying to achieve?
Right.
Inference itself is quite useful, and has all these really unique properties of using different sensors and different and missing pieces of data, and then won't get confused by various things. But so how would I apply this to something?
Well, we can also do predictions because we have time there.
Well, the time is more of a history, right?
No, but if we have, if you know what something was at a certain time, you can make predictions something will be. Come on.
Yeah, well, imagine my graph in the episodic memory just knows where everything is the last time I looked at it. It just says, okay, the last time I saw it, I like the food on the table. And you sit down at the table, you look at all the different plates, and instantly you form this memory of where the different foods are. And so that just on its own saying, okay, where was that thing over there? I know where it is. I can't even see it anymore, but I know where it is. Or I'm at a different point in the room, I know where it is. So I'm not sure if it was, I probably didn't answer the question. I didn't understand the comment. We're sliding into this capabilities thing, right? So imagine that we have this system, what do we want to do with it? Now I keep coming back to surveillance issues. I hate doing that. But that's why I always like, imagine you're watching something in a factory, as opposed to people walking on the street.
Just kind of thinking agriculture would be a nice alternative to, you could surveil crops instead of surveilling humans.
Yeah. We looked at agriculture issues in the past here, and one of the problems with agriculture is that the data is very slow changing. You could build a model, you could look down and say, oh, I see patterns here. You could build a graph, you could be looking at satellite data and sort of looking at the picture and trying to figure out things, but there's not much of a time component to it. It's very slow. I think it'd be better for sort of dynamic systems. It might be too much to ask this group to figure this out at the moment, but I think Kevin's question really gets at the heart of what I meant by my second point here, is we want to figure out what we want to demonstrate that's valuable and surprising and quite, remarkable. And if I just think about it broadly, like inference is the kind of thing that people want to do. They're like, what is this? But now you can do it in a multi-sensory way, different configuration, using a lot of nice capabilities. You can do it. You can do it not just with static things, but with dynamically changing things, so that you could see. It's not like, oh, we have this training set, and now we're just going to know the 1,000 categories. It could learn new arrangements of them constantly. Another question is, would we really want to introduce anything that's more of a robotic nature that actually does something physical? That seems to open up a big can of worms. Although this architecture should support it, it opens up a big can of worms about complex applications. I don't know about that yet. So maybe this is the two ways I was thinking about this is Subutai had this very good list of technical questions. And that's why I thought it'd be nice to have him present that. But then I do think just the next big thing we have to decide is what what do we actually want to demonstrate? What do we want to show that people will go, holy shit, that's amazing. And we may not be able to solve that today. I think we want to get started on implementing this stuff. Even if I don't know that yet, I'll get that soon enough. Okay, we'll go with them.
I think we need to resolve these things though before we can implement
Well,
anything.
how are we going to resolve them? How much time do we want to spend debating it before we pull the trigger on something?
Shouldn't we like try a few of those and just get things going?
What
That's,
was the first sentence, Lucas?
can we just like try a few of those things and get things going? Just because when you put it into words and just ideas, it's hard, at least for me, to conceptualize and actually, you know, see it working. Maybe we can try all those ideas, you know, make small projects, like a week project, see how it evolves, and come back with feedback.
What do other people think of that?
I think it'd still be nice to have a end goal, or just a load start to say we want to be able to demonstrate this and which of these things.
We will. We'll have to do that. I've been through this before. It's very similar to me. You sometimes just have to get started with uncertainty. It's just the way to, when you're doing big things, you just cannot resolve all the issues. You just have to pick something and go and learn. So you spend some amount of time up front just trying to figure out, okay, let's take our best shot, but this can't resolve everything. So I mean, that's why I'm partial to Lucas's suggestion. Until Marcus brought up his suggestion about these autoencoders ideas, I said, okay, we can build this. We can build this using the mechanism we had in the Collins paper. And how to do that. We can get started on that today. We can walk through that. But now we're going to seriously consider other ones. Either we do multiple ones, but I don't want this to go on for like, you know, months of research here. We need to pick something. We need to get going on it. I do know how to. I think I know how to do the neural one, the positive one. Does anyone else feel comfortable with that too? I assume you are.
Yeah, I know how that works.
Yeah. So we know how to get started on that. I don't know how to get started on the idea that Marcus was proposing. So Marcus, you'd have to answer that question.
I mean, I essentially know how to get started on it, yeah, but it's, yeah.
Jeff, what's the idea that you want to get started?
It's just the mechanism that exists in the voting mechanism. It's just an associated learning between representations in each column. And the union was used primarily as the method for representing uncertainty. And I mean, as soon as I went through that, we can do it again if it's not in your guide.
And to me, that mechanism is easy to implement. The hard thing to me is how do you calculate location relative to the body and orientation relative to the body.
That seems like that would be an easy one to do. Oh, interesting.
Yeah, given that, that's again, it's the sort of doing this reference frame transformation, going from sense SD to OB.
Well, what if you
That's the hard thing.
what if you represented them in polar coordinates?
So I thought you were gonna say computing the SB is the hard part.
Sense of the body?
Yeah.
That's just a forward.
Okay, I was thinking like currently somehow taking a convolutional neural network, taking an object and outputting both ID and pose. I thought it's doable, but that's something we haven't done yet.
Do you even have to convert it from SV to OB? Because what if you just have different representations based on how you're perceiving it, and then different sensors will have those representations sort of link up based on what's firing it.
No, I don't think it's possible.
Because then it'd be changing constantly. They'd be not associated.
The whole trick works because the whole thing works because there is a common reference point. If you didn't have the common reference point, I mean, that's why it works. So if you didn't have that and you just have this combinatorial mess, you can't figure it out. As Subutai said, your fingers are constantly moving. The rest of the brain can't figure out where your finger is.
Well, I didn't say that.
No.
I think the brain always knows exactly where the finger is relative
To your body, yes. But
I think the
it-
SB is,
No,
no,
my point, yes, that's
No,
not.
I didn't say, sorry, did I say SB? I meant,
Yeah,
I
you
meant,
said
I meant
SB.
SO. I mean,
I think you're thinking, how is it that the individual modules know the pose and orientation of the object?
Yeah,
yeah, that's the OB, isn't it?
no, okay, it starts with SO and then becomes OB.
Yeah.
Or SO to BO.
Marcus is saying,
Okay.
the hard part is,
So I think we actually agree, we were just saying it. in
Yeah,
different
yeah,
ways.
if I use a convolutional neural network to recognize this as a pair of glasses, how do I extract out the distance and the orientation of that glasses so that I can represent it? I think that's what you're saying. The
Yeah, and
convolutional-
the next time if your glasses are in
Yeah,
a different
that has-
way, the
it'll say-
OBs should be the same.
the OBs should be the same, but the SOs are different.
Yeah.
But you have to know the SO first.
Yeah, so to me, figuring those things out is really the hard part. Doing the voting, the columns paperwork is
Right,
easy.
right.
So it's not
Right.
an issue at all.
So as I said in the very first time I presented this, that the thing we have to do first is define the bus parameters and the bus architecture. I didn't say it was gonna be hard. It could be really easy, but we have to define it. We have to pick one and go with it. And so if you say, that's trivial, I know how to do that, great, that's trivial, and I do it, let's do it. And then secondly, we say, okay, now we want to start putting things on that bus that have to output the correct information, and that makes it harder. Right? That I think you're saying is harder. Like, well, we know how convolutional neural network would tell me this is a pair of glasses, but how do I get the orientation from that? And how do I get its distance from it?
To me, one is like a couple of days implementation. The other is like an open source research project that I just don't know how to solve. So it's like, it's two very like dramatically different kinds of
Okay,
things.
fine. I think that's great. I'm under the impression, and Marcus has hinted at it, maybe I'm wrong, but I think we could solve this problem. There's lots of ways you could solve this problem. Maybe we don't know the best way. Maybe we'll have to do, some crazy stuff. I mean, the distance from an object to something could be easily determined. And you could have multiple sensors. You could have a camera, you could have one of those cameras that detects differences, distances. You can, but then how do I get the glasses a different orientation? Maybe I just overly train the system and I have a representation for 20 different orientations and, I represent it that way. I don't know. You can do all kinds of, wackadoodle things to make it get started.
So, we talked about doing sort of these unit test properties,
Yeah.
listing those out. I didn't have that on my list, but that's something I talked to Lucas about really.
Yeah.
I think that would we just talked about one, that if those would be useful to list out.
Well, to me, the first thing I would do is I'd get the bus defined. If I don't care if it's trivial, that's good, right? It's simple, but at least get it built. One set of unit tests would say, I'll just hard code the output for one of these modules just to make sure I can do the right queries if this module was working. How do I send information back and forth? Do I need an attention mechanism? Do I need, there's a bunch of stuff. I don't think it's trivial. So you could build a set of unit tests on the bus itself. Then you could start building modules and you could say, okay, well, I'm going to do a visual module. How am I going to get to work? And that's a whole separate development exercise. It might be much harder and it may have its own set of unit tests. I don't know.
I guess I had one question that was at the level of posed in the beginning.
That question up there, that was something.
Yeah, one question at that level, which is what is the relationship between modules and cortical columns? And that part is not clear to me yet.
Well, it's not clear to me either because we thought that maybe, recently we started thinking that what we think of as a cortical column is really a what column and a where column. Because all the functions that have to be performed in this box are a what column and a where column function.
Right.
So,
but so that's one question. Another one is.
but I don't know if that's important right now, is it?
But is a module, like all of vision could be one module, or do we need thousands of modules similar to cortical columns where each one is looking at a small patch of an image? To me, those are has pretty big implications.
I guess to me, it's the output of the box which matters, and the input of the box that matters. And using a convolutional neural network for vision, doesn't rely at all on the many columns local voting stuff. And so that could be like an eyeball, if you will, one eyeball. And you could have many of those, you could have multiple eyeballs, and in brain that might be 1,000 columns, but here we don't need to do that. But we might in the future just decide to implement this more brain-like and divide it up into, you know, subcomponents of columns or something like that. Again, I think if some of these questions are, we can, if I just say what does the input and the output of this thing have to be, then you just a separate little problem, and you have to say, okay, what's the best way of implementing it? I'm imagining right now we could build some of these like division ones with a CNN and some glue around it and some other components and get it to work. And at the moment, I don't care if it's not biological. It doesn't matter to me at this point, because I want it to communicate properly. So that would be again, if we define the bus architecture, then we can tell you what this box has to do, and then you can start thinking about how you would build those things.
Well, one take is, you know, I could, you know, two extremes are, one is we could do everything with SDRs. Maybe we do instead of binary SDRs, we do real valued SDRs, and everything here I know how to do pretty much. The other extreme
Are you
is,
good with the location orientation? I mean, location
well,
orientation,
they'd just be SDRs.
but how are you internally representing them? I mean, like I'm thinking polar coordinates, but
Yeah, we could just pick some
okay.
coordinate system and do
And if you
encoder
want to do
coordinate.
real valued SDRs,
Well, if we're going to use,
would that work with the associative memory kind of linking?
I think so. I think we're doing deep learning. If it's going to integrate with deep learning stuff, then we'd have to have real valued stuff right now in some way.
Again, don't worry about deep learning. It's the output of the bus here that matters, right? So you need to have some representation of orientation and location. And at this point, it's nothing to do with deep learning. It shouldn't matter how I implemented this in here. It makes no difference whether I did this with, you know, neural neurons or deep learning. It shouldn't make any difference. So the question is,
Well, my concern would be we might eliminate deep learning if we use pure binary. I'm not sure if that's true or not, but that's what my concern would be.
I mean, whether it's differentiable across the,
Yeah.
are there alternatives that don't require that prop that would be available to
That's the
some
whole research.
No, I understand this. I mean, are there, I mean, it's a literature search at this point, right?
can I just,
No, that's an unsolved problem.
It's
so
unsolved.
Subutai,
Yeah.
leap learning comes out and gives you top best vision system and gives me a top 5, right? Classified. Why can't I represent those with SDRs?
Well, if the system is going to learn,
I have a system here. It has some top. You have some classifier on it, right? And now I have some output from the classifier. I put those in SDRs.
yeah.
Also, I
we
need to
could
go
do
the
it.
other. I need to go the other way. I need to go take an SDR and turn it into one of these
Yeah,
objects.
we could do that. We could create encoders.
Those are encoders.
We could create encoders of arbitrary resolution.
I'm a little bit neutral right now whether the bus should be binary or not. I don't have a strong opinion about that. But if you start going to non-binary SDRs, then I have the question like, well, does the associative memory system continue to work or not? And it might, I don't know. We can talk about it.
Okay, we could do binary SDRs that.
I'm not
represent-
pushing for that.
No, I'm just saying, I'm just thinking through it. We could create encoders to do, you know, polar coordinates and
Yeah.
location, you know, orientation and all that stuff.
I think the thing about right
I'm
now,
just saying something that's close to the columns that I can articulate.
yeah,
Then the other end of the thing is what you talked about, is the other extreme, and we could
the
do that one too.
let's take the polar coordinates one. you don't want to just have some random word, SDR for every position in polar coordinate space. There you really do need to have similarity.
No, but yeah, no, I'm assuming that.
Okay, well, the object ID, we don't have similarity, so,
Well, there's a question there.
well, at the moment, we don't know how to do that. So,
But and that's sort of a natural output of the.
okay, the comms, okay, fine. The comms paper did not have any
Right.
kind of concept of similarity.
Right.
So you'll have to output an SDR that does have that. And if I think about like how brains represent, you know, vector cells or direction cells and things like that, it's not a big SDR, it's really kind of small and it's not that sparse even, you know, there's a bunch of cells that represent different positions and there's like a bump that moves around like, you know, so it's not like this big high dimensional vector.
Right, but we have encoders for that already. On the old Rubik days, we have location encoders and we could do any dimension.
Yeah, we did all that. Oh my God, that was really clever. I forgot about that.
It was like some kind of random.
We did it with the we did it. We were able to encode infinite
Your
spaces.
spaces.
Yeah, no, that's really cool. Forgot about
So
that.
to me, that's, you know, if we want to do binary SDRs, we have all of that available.
Okay, well, I think that's an important property that
We can
the,
do it at arbitrary resolution. You know, we can just pick,
well, I think that's something.
you know, how many, what
This is-
degree we want.
This is something that we can do much better than a brain. But the point being though, is if I have a very precise location, I can tell you, oh, exactly where that is, you know? But I also have to be able to say it's somewhere in this general area, or even in the bigger general area. I need to be able to represent all those. So that's where the uncertainty comes in. I'm not sure, you know,
Yeah, that's this question.
I'm not sure if that's it, you know, the way I think about in the brain root, like it's this bump of activity where all the cells around that bump have similar representation, more like, you know, grandmother cells with a bunch of them active type. Well, I think those are things you figured out, but the point being, I need to be able, you can have high precision, but I also need to be able to represent ambiguity in location. And ambiguity in location is not like ambiguity in ID, object ID. And ambiguity in object ID is, well, that could be could be a coffee cup or it could be a car. We don't know how to do this yet. So, but here I have to be able to say, you know, it's a rough area or narrow it down.
So could that just be a union?
Well, I don't know if it could be
It's a-
union because you just, well, it might be. I mean, unlike again, you know, I guess the union, you might say, oh, it could be over here, it could be over here. It doesn't seem like you have that kind of ambiguity. It seems like you have more of ambiguity, like, oh, I'm this
Yeah,
area.
but could it just be a union of all the
It
SDRs?
could be, I suppose, as long as it works. You know, imagine you had a very high,
I think voting would work.
imagine you have a you have a polar representation space in this room from here. So I'm in the corner, and from my position, what's all the points in this room? Well, I can come up with a very high resolution polar map of this room. And that's great. But I also have to use the same bits to represent a much fuzzier one.
Right.
And I can't be, a fuzzier one can't be, oh, the million bits in that around Karan's head, that's the ones we want. That's too much, right? Humans can't do that.
Can I ask a somewhat related question on the abstraction? One of the key parts of assembling something from the group of parts of the skull is knowing whether this is connected to this. That's something that that a convolutional network doesn't do a very good job of. It basically, it learns a whole bunch of relationships that eventually comes down to the fact that implicitly they must be connected, but it goes through a
Connected,
whole,
what do you mean connected? Physically connected?
visually adjacent to each other.
So whether you want to say, you need to know what things are relative to each other. Do they have to be
I
connected?
know, different.
Why?
Topology as opposed to geometry. You're saying that I need to know polar coordinates of this, this, and this, and by inference, they must be close to each other. I'm saying, is there a way of actually parsing the thing and saying, this is connected to this and this? It could be a squashed representation of a
So I think
bicycle.
you're mixing two things up, Kevin. I'm just talking right now, purely representing locations in space. It says nothing about what's there. Absolutely nothing. It's just, this is a location in space.
Right.
It's a separate question, how does the overall system know what things are combined or not combined?
Well, yeah, so you're saying I only need to know the position space of the entire object, right?
Of the entire object at the level being recognized down here, yes.
Okay, so The problem.
It might be just a subset of the bigger object.
The problem you're facing right now is how you can do that, but how do you do pose? And one of the ways to disambiguate, you don't need necessarily have the pose if you recognize that the thing is an ensemble of parts, and then you have an invariant, which then you could represent as a graph, you know, no matter what the position is. So is, do you understand what I'm trying to say? It's
You're talking about like joint angles that they're constrained by one another.
well, if I have a crab version of a representation of a bicycle, and I'm not talking about bag of parts where it would be, you know, this disconnected from this, but the critical notion is that this is connected to this.
Oh, I would argue that's not the critical notion. The critical notion is that they're in relative positions to each other.
But if I did this, even though the joint angles are quite different, you'd still say, okay, that's kind of like a bicycle.
Yeah.
Okay, so you want to be able to abstract away the geometry and just have the
No,
topology.
I guess I think we're looking at two different ways. To me, the answer here is you're learning the relative position of parts. And that's the key item that's being learned in the system.
That's the problem when you say position, that implies a metric.
Yeah,
I'm saying that
yeah,
you could still recognize it even if things.
yeah. But so you have a graph which says where things are relative to each other.
Right.
Okay, hang on. But now as that graph gets distorted, you can still say, well, it's not exactly, but it's still things that are similar in relationship to each other. And at some point it starts breaking, right?
Right.
So I don't think of it as the connectivity as the issue. It's really the same, all the arguments you're making were made about the relative positions of things. You know, after all, what if the part of the bicycle was obscured? It was a railing that cut across, you couldn't see part of the frame. You'd still see it as a bicycle, there'd be no questions about it.
Right, there'd be a subgraph that would match.
No, it would be that almost everything in a graph would, yes, would be a sub, which part of the graph is missing, maybe the people components. The point is, it's not that I determine connectivity, it's I'm looking at the relative positions of things, and there's an assumption that it holds.
It's funny, that reminds me of the stretchy bird. The stretchy bird experiment.
Oh, yeah, yeah.
So you're saying
Yeah,
that in your scheme, as long as they're in the relative positions, even if they're not physically connected, that
well,
says.
if the bicycle requires it having a frame, and I saw all the components of the bicycle without a frame, I would say, well, that's kind of like a bicycle, but it's missing a piece. The frame itself is one of the objects that's in that thing. It's not just an edge of the graph. It's actually a thing.
Right. I'm just trying to.
I mean, it's a type, we're trying to get at a type of similarity between objects there.
Correct.
That are
Topologically the same.
Topologically the same. It doesn't necessarily have to be connected, they just have to be, you know, so you could have relative positions between those things that are very, very different,
Right.
but still the same underlying topology.
Right. I'm hypothesizing that the ability to associate things together by connectedness is a direct representation of the graph.
I think that this idea will fit in at some point. Building topological maps of objects, topological graphs, being able to see that the example I've used before is a cat, and it always has this arm that's connected to a body, and you see cats in different poses, but there's some similarity between them. It's the topology. I think at some
That's the
point.
same thing I've been talking about, the morphology problem.
Yes,
Okay.
I think we think it's related to that.
All right,
So
so
my point
okay.
is there's this cluster of ideas that yes are important.
But this, and this is really hard for a CNN to say this is the same
So what
unless you train it.
So what we
on
would
those.
do in this case, the CNN, we would have it attend to different components of this. It would attend to those three different components, it says, I don't recognize this object, so let's now attend to the different components of the image.
Okay,
And now we build it up temporarily, we build up a graph, well, we have these three things like this, and I think Marcus has hit on the right thing. He and I agree that there's a missing component of this, which I was calling morphology. you might want to call it topology.
Well, just that this thing's the topology, or
Okay.
you're describing.
I think
I'm
there's
not sure.
another component besides the relative position of objects. And I talked about that recently, and it bothers me because I don't want to be the more things we have to learn, but there seems to be. The moment we're thinking about this, it doesn't include that. So again, this is version alpha we're talking here, right?
Right.
So the question is, can we make a version alpha that's really cool and useful? I think we can. And then as we develop it, we'll develop more ideas and the second generation and all these other things. So the bet here is that we can come up with an alpha version of the system that is actually works and does something very useful. And it may not solve all these problems. So that's, and so we know that. This is another problem. It's not going to solve the behavioral problems, behaviors, etc.
Right, but I guess I'm just coming back to the issue that Subutai mentioned of, trying to discern pose. And I'm trying to abstract it down to something that might be easier to solve in a certain fashion rather than, I mean, you can throw something at CNA, you can show a rigid object or its orientations, and eventually, slowly, it will learn, that these are all kinds of the object ID, but it's kind of a brute force thing.
Yeah.
And I'm trying to say that if we could break it down to a much smaller thing, to say that this is connected to this, these things somehow move together adjacent to each other. No, you don't have to look at the entire thing at once. As you say, you can attend, but the notion of,
you want to know if it's physically connected, and I'm arguing, no, I don't want to do that now.
I was saying if it's visually connected, then you can start building up from
Physically connected, so.
All you can see is visually unless you touch it. I mean, you could put these things in arrangement, so visually it looks like they're, but if you go to this thing, oh, they're disconnected, it's an illusion. But that's kind of the basic thing when you want to associate these things. And that will work no matter what the scale is and what the orientation is and where you are relative to that. You can say something about that you could maybe recognize.
Just for what it's worth, Kevin, I agree with you. I think that there's a problem with the brute force approach of training vision models to do it this way. I think it's a pretty widely accepted criticism in the field. And some of the stuff that I've been trying to get a handle on is the neurosymbolic. And what you're talking about is closely related because it involves a step of abstracting out individual parts. So there's an abstraction step and then a composition step. So you break it into parts and you figure out ways to combine them.
So
we know in reliable, I don't know, with V2 or V3 that there's a notion of end stop on line segments, which kind of relates to.
Maybe I think I have a whole other theory about what those are doing. So
all right.
We can't go there. I think what here's again, what goes on in this box is going to be tricky, right? It's going to be really hard to do. So we want to build something that works today, even if it's brute force, but something that's going to meet my requirements up here. And that can be brute force for starters. As we go along, we can improve upon it. We can do all kinds of variations on this. The beauty of this architecture is that you can get started today with something useful and not wait for us to figure out all those problems. That's the challenge, right? That's what I was confronting. We're looking at a roadmap, thinking, how are we going to integrate reference frames and so on? And then I realized, we can build the whole architecture and get it working on a subset of what we'd like it to do eventually. It'd still be very useful, not a toy problem, not a toy system. And then over time, us and other clever people can figure out how to build these things, how to improve upon them. So the ideas that you have, maybe those are the right, maybe it's different, maybe it depends. I don't know.
I guess what I'm looking at is I'm worried about the contents of that box being fragile. I mean, you could build all this stuff around it.
So one of the beauties of this is, what if it was fragile? I now give you 10 sensors that are all doing similar things that are equally fragile, but together they won't be fragile.
Okay.
That's the beauty of it. That's the thing. It's like I'm looking at it from three different directions, from three different sensors, and in the end, we're going to get the right answer.
I had a maxim that goes back to when Subutai and I worked together, is never put computation in the space where a sensor would give you a direct answer. So in that sense, you can simplify things. tremendously by doing that.
Yeah, that in some sense highlights the advantage of the bus. Right?
Right.
It shows that I might be better off having 100 really trivial sensors here,
Yes,
right? I mean, that might be the right answer.
right.
Just like little stupid things like a fly's eye, a fly's eye, little things all over the place, a bunch of stupid little sensors that are really fragile or just don't know much, but put them all over the place and they all try and they're going to reach the result.
Yeah, I mean, we have to infer depth, but
Well, I don't know about inferring.
no, I mean, our eyes have to infer
Yeah.
depth. You could actually directly sense it, as you pointed out.
Well, I think determining depth is, you could build sensors that literally measure depth, it's like,
No, I understand, but there's a lot of just looking at a two-dimensional set of pixels that so much has to process to do that, that, as you say, if you add more sensors, modalities, whatever to the thing, the problem becomes easier if you have a way of integrating them. It's an interesting
and that's
way.
what the bus does that.
And so that's a powerful thing.
That brings up the interesting question we should consider is think more about this idea of building really simple versions of this, really simple.
That's kind of like a Coracle column.
Yeah, it is. Well, protocols are not so simple, right? We know that. They're pretty damn sophisticated. But what if you, that's a very interesting question about, I'll have to think about that more. We can all think about that more. Like, what if I gave you 100 trivial sensors versus one sophisticated sensor, or 10 sophisticated sensors? 1,000 trivial sensors versus 10 sophisticated sensors. What would the implications for learning and modeling?
Flies eye.
Yeah, I mean, in some sense, if you're going to build up a graph over here in the episodic memory, and nobody knows more about really trivial things than your graph is going to be built up. You're going to be starting at a lower level of concepts. Well, all right, so that's an interesting dimension of going multiple and small versus fewer and complex. And I can, oh God, sorry. Yeah. I was trying to think about how we actually build one of these using multiple columns, just like we said, and what kind of local voting would you have? So there might be what I was really thinking about at one point, you might have a system bus here, but then you might have local buses on the different sensor modalities. And so you have different columns planned to these, and then you have these planned to these. And so that may be really the way the cortex is built. And I was trying to avoid that. I was saying, well, if we could put a lot of smarts in one of these modules, then I could avoid thinking about this hierarchical construction.
It's not routing.
Well, it's more than routing. It's more of a physical. These would always vote together before they vote up here, that kind of thing. I mean, I wouldn't route this low level column to this low level column. I might, but I don't think so. Anyway, the brain seems to have this sort of tiered hierarchical structure like this. And when I was trying to think about attention, and I was saying, well, how do I attend to something? Well, I kind of narrow the area of the world I'm going to receive input from, but I'm still going to get multiple columns. So I have a set of columns that are going to at one point represent a small feature, another point is going to represent a bigger feature, and how's that all work? And I was going down a rabbit hole on that. So I said, oh, can we just get away from that? Can we just like build a system that has maybe a fragile but fairly sophisticated thing that these modules can recognize all the things that the ultimate application cares about, right? Imagine you're doing the bin picking problem, like parts all over the place, and you're trying to figure out what are the part you're looking for and something like that. And could you tell, okay, systems know the 50 different parts that it has to find, and there's a bunch of sensors, and they're all looking at different directions, and together they can decide there it is, that orientation exactly. Whereas a single camera can't do that. That could be good.
Yeah. Well, it is a bifurcation in architecture.
Which way?
The one that you made between few sophisticated,
yeah.
many, and small.
Yeah.
And if we had, sufficient amount of resources, you would send one team down one path, one team down the other path, and see and then synthesize, what the good parts of both might be.
So this, just to make sure, I want to make sure everyone understands this. The ultimate way I believe this is going to play out, go 20 years from now, there's going to be a huge industry of people building components and deploying systems. It's a classic sort of technology play where there'll be lots of people come out and say, oh, I have a special sensor technology, or I have a special sensory motor system that I want to build and make it do certain things. And so my point of saying this is we don't have to do all these things. It's impossible. We're not going to do any of it. In the end, we're going to be defining the bus and maintaining the bus. And there'll be 1,000 other people doing all these things. This may seem highfalutin to you, but just give me grins, accept it for the moment. So we just need to get the whole system started, right? We need to show how it can be done, how you can build these things. Here's how it works. Then you need to open it up to other people, and there'll be many people trying many things, and they'll be cleverer than we are because they know their domain really well and they know their application space very well.